Okay, the handout that I gave you today in class had the angles positioned in the wrong spot. So I have adjusted those angles so that the 30-degree angle is opposite the shortest side of the triangle and the 60 is opposite the longer leg of the triangle. I would like to identify the hypotenuse, which is always opposite the right angle. So we'll put hypotenuse over here. The short leg I'll identify with an SL. And the longer leg I'm going to identify with an LL. Now, what is the relationship between those three sides? If I assign the variable x to the short side, we know that the hypotenuse is 2x. Now, I'd like you to please look through those old notes that I gave you. I mean, we went over plenty of examples showing the relationship in the 30-60-90 triangle. And then the longer leg is going to be x times the square root of 3. So those are the relationships that you should have on your triangle. The short leg x, the long leg x times the square root of 3, and the hypotenuse is 2 times x, which would be 2 times the short leg. In the 45-45-90 right triangle, we know that that is an isosceles right triangle. Hypotenuse is always opposite the right angle, so we have the hypotenuse there. And we have each leg of the triangle being congruent. Now, those legs, if we assign the leg the variable of x, that means the other leg would also be x, and then the hypotenuse is going to be x times the square root of 2. Again, please look through your old notes to look at the many examples that we did on this. So that is your relationship. If the legs are x, the hypotenuse is x times the square root of 2. Then for the geometric mean problem, that's the situation where we have the altitude drawn to the hypotenuse of the right triangle. I'm going to assign some variables to the sides to make my life a little bit easier here as we are talking about the geometric mean situation. So I've identified that each leg of the right triangle, x and z, the altitude drawn to the hypotenuse, I've put in a y. I'm going to make AD equal to the lowercase a. dB, I'll put a lowercase b, and then for the length of the whole hypotenuse, I'm going to call that c. So according to the geometric mean leg theorem, each leg is the geometric mean. So let me put each leg in the geometric mean position. So x is the geometric mean between the whole hypotenuse, c, and the piece of the hypotenuse that's adjacent to that leg x, and that would be a. The other geometric mean would be z, so let me put z in the geometric mean position. And z is the geometric mean between the whole hypotenuse, c, and the piece of the hypotenuse that is adjacent to that leg, so that would be b. And then the geometric mean altitude theorem says that the altitude y is the geometric mean between the segments of the hypotenuse. So the two segments of the hypotenuse are A and B. And you should please look over your examples for further review for tomorrow's quiz. The last question here asks us to please write the similarity statement, the similarity statement for the three triangles that are similar. Okay, so using our diagram, I'm going to start with the large triangle ACB, and that's similar to the triangle up at the top here. The smaller triangle shares angle A with the large triangle, has the right angle at vertex D, and then I'll put in the last angle C. And that's also similar to the triangle, the medium-sized triangle here. The right angle is in the middle at vertex D. It shares angle B with that first triangle, and then the last angle is angle C. Now, triangle ACB is similar to then triangle ADC, which is similar to triangle CDB. Remember in class I told you that if you have a difficult time identifying these triangles and making sure the vertices are in the right position, put numbers in your triangle to help you verify. So if I, for example, put a 60 up there at vertex A, a 30 at vertex B, And then we can see in our right triangle, this angle would be 60 degrees and this adjacent angle would be 30. We can check to see how did we name our triangles. Well, I named it with the 60-degree angle first, the 90, and then the 30. So 60, 90, 30 for angle, or for the first triangle, 60 degrees, 90 degrees, 30 degrees. Then for this triangle here, I named it 60, then 90, then 30, and then the final triangle, again, I have the 60-degree angle, the 90-degree angle, and then the 30-degree angle. And there you have it. Please use your old quiz for review for the extra point quiz tomorrow.